Star Trek's greatest promise is to give us hope that someday we will be able to travel to other planets.
We want to find planets around other stars out of a sense of self-preservation.
One of the ways we can ensure our longevity as a species is to actually spread out into the universe.
We don't exactly know how long our planet has a future.
Humanity would never identify a place and not attempt to go there.
Many things that used to be thought of as science fiction are now science fact.
Can we imagine traveling to the stars, a la Star Trek?
The idea for Star Trek, both the 2009 film and Star Trek Into Darkness, was to take the spirit of the original series and make it relevant for today.
Give it up for Captain James T. Kirk! Give it up!
I think when you look at what it is that Roddenberry did and what he literally wrote about going boldly where no one has gone before, we're trying to do that, and I would hope he would appreciate that we're honoring that sentiment. So we really wanted to make sure that when you looked at this movie, if you're a fan, you go, oh yeah, that's Star Trek, I know what that is. But we couldn't be making this movie for fans of Star Trek. We had to make it for fans of movies.
Hello, I'm Montgomery Scott, and I don't work here. I work on the lower part of the ship, but I'm not allowed on the bridge at the moment because JJ's picking where everyone goes. And I don't have a place, which is why I'm in the turbo lift.
Yeah, camera stand 2, 3.
3, 2, 1, and bang!
It was all about trying to acknowledge and honor the spirit with which Roddenberry created the show and the design of the ship. You know, how do we take the original design of the ship, make it uniquely ours, but also keep the general sense of it, the dish and the nacelles and the hull and the general shape of what we know, so that, again, it feels like, oh, yes, that is the Enterprise. And we worked really hard to make the ship feel real and sort of epically large.
The interesting thing about the Starship Enterprise, the design of it, is that if I look at it as a scientist, nothing really jumps out at me as being wrong. It looks kind of practical. I can't think of anything in the way it's put together, the way the engines are located, where the crew lives, that says to me this couldn't work.
What I love about the concept of the Enterprise is the self-sustainable nature of the city that has to exist within that spacecraft.
What you have to do is visualize an aircraft carrier. That's got a few thousand people on board, and you've got to feed them and provide them with water.
You need communications people, science people, you need engineers, you need a command.
There will have to be medical technology, schools, waste treatment.
You have to have an energy source.
Some means to have a great amount of energy stored that you can deliver to these propulsion methods in a very controlled and safe manner.
You need to be able to get there in some way or another fast enough so that the people who start out on the mission can ultimately end up there.
On the last film, we had the sets built on different sound stages. We had a bridge on a separate stage from the transporter room. We're shooting on a new soundstage this time, a much larger soundstage.
Enemy of my enemy is my friend.
An Arabic proverb attributed to a prince who was betrayed and decapitated by his own subjects.
Still, it's a hell of a quote.
I will go with you, Captain.
No, I need you on the bridge.
I cannot allow you to do this.
In this film, we wanted to really make the ship feel as large as we could. We built all the pieces of the Enterprise all on the same stage, and it was all connected with each other. So you were able to leave the bridge, walk down the hallway, which turns into a big atrium, and then that goes off in all different directions. You could continue walking and walk right into the transporter room or walk over into the infirmary. And there were more turbo lifts all over the place, so you really start feeling that the Enterprise is a real place that you're walking through and not just sets.
And action!
If you think about how you would want to build a spaceship that could really get across the galaxy, I think the Enterprise is a really good model for it.
Okay, so let's cut.
As a kid, and I first looked at it, I was so glad that it was not a rocket, and that the layout made you think, why did they do that?
I think the main thing was to completely break from the old Buck Rogers notion of these arrow-shaped ships landing on their tails. The Enterprise, it's a naval ship. It's like Captain Cook discovering Australia, or the HMS Beagle, which carried Charles Darwin. These ships, they had war-fighting capacity, but in addition, they carried scientists. The captain could sign treaties. He could negotiate.
Withdraw. I'll agree to arrange a conference with Romulan leadership at a neutral location.
I do not speak for the Empire.
This naval vessel contains our civilization. And this is how we're going to travel between the stars.
I think as a kid, I was more inspired by science fiction that I'm sure had been inspired by actual science. The idea of genetic mutation, for example, extrapolate that, and you've got Godzilla or The Fly. The idea of space travel and what does it mean to be isolated for such a long time inspired Rod Serling to write the pilot for The Twilight Zone. There's sort of quantifiable examples of science-inspiring entertainment that inspired me. Growing up in a generation where people had been on the moon and in space, it was always an incredible accomplishment and an amazing thing, but it felt like a little bit par for the course. Like, oh yeah, people go into space. That's possible. I think the generation before mine, the idea of space travel was crazy and a miracle that it occurred. Space travel for me has always been kind of a tangible, real thing that was normal as opposed to extraordinary.
It used to be thought science fiction to go to places like the moon and Mars. And now, of course, we've had people on the moon and we've sent robots to Mars. In 1902, well over a century ago, there was the first science fiction movie, A Voyage to the Moon, where people went to the moon and met up with strange creatures there. Already, it's clear people wanted to go to the moon and were dreaming about it.
It's been over 100 years since Voyage to the Moon. I can only imagine in such an early stage of film how mind-blowing that must have been to see that movie. Since then, a lot has changed and nothing's changed. It's changed in that while we know what the moon is made of and we've been there, we have so far to go. That just goes back to the most important thing that's never changed, which is the goal to understand our place in the universe and to understand what's beyond this place that we live on. That curiosity and wonder and desire to explore.
I don't have any doubt that if we came up with an interstellar craft that could go to another planet outside of our solar system, that if we told them it may be a one-way trip, I think we'd have volunteers. People want to find out what's out there, and the stars are the ultimate frontier for doing that.
If I was really going to do that and could do that, I mean, I would come to terms that I'm never going to see my family again and would, say all the goodbyes and stuff like that before I left. But still, even with that disconnect, I think it would be a really cool thing to do.
If we look at how we have evolved as a species, it's one of branching out and going into new areas and trying to understand. And we have done that on the entire surface of the globe. We have research stations in Antarctica. We've done it into the deep oceans. The only other place to continue to explore is upward. Can we ever get to a planet in another star system? Can we get to a distant civilization? That's, I think, the more difficult question to estimate.
Can we imagine traveling to the stars, a la Star Trek?
We have to do this now. I told the captain the shuttle wasn't built for this kind of heat.
Captain, did the indigenous life forms see you?
No, Mr. Spock, they did not.
The Prime Directive clearly states there can be no interference with the internal development of alien civilizations.
I know what it says.
Many of the concepts in Star Trek seemed fantastic and fantasy-like. The more extravagant aspects of Star Trek, we still don't know how to do them. But many of them are already true now.
Scotty, it's Kirk.
The communicators that Captain Kirk used are very much like the flip phones that are themselves obsolete now.
Yeah.
One of the great things about our civilization is we want to reach out. That's what science does. That's what Star Trek does. Albert Einstein said that if an idea does not sound absurd, there's no hope for it. What he meant is if you're going to push the envelope of science, there's also a need to push at the frontier. To do that, you have to reach out and pluck an idea that is going to sound absurd at first, until something that really looks absurd starts to look true. Absurd, but true.
As I think about one of the physicists who's most responsible for the Star Trek universe, I think about the revolutionary nature of Einstein's work.
Albert Einstein created the theory of relativity, which described the way the universe actually works.
Einstein's theory of relativity gave us a source of energy, namely nuclear energy, that could power a spacecraft like the Starship Enterprise or propulsion systems of the future. On the other hand, Einstein's relativity unfortunately imposes a constraint, which is the speed limit of the cosmos, the speed of light.
The speed of light is about 186,000 miles per second. It's the absolute speed limit beyond which no material particle can travel through space.
So Einstein, in a way, giveth and taketh away. He gave us a way to power a spacecraft that could take us to the stars. But he also gave us a clear limitation to how fast we can go.
Einstein was the one who realized that the faster you push something, the heavier it gets.
So it's like starting out with a mouse, and you begin to move the mouse, and the mouse begins to turn into an elephant. It takes a lot more force, a lot more energy to accelerate the elephant than the mouse.
To move anything, even a speck of dust, at the speed of light would take an infinite amount of energy.
Infinite energy, which is kind of hard to get around.
So that was the genesis of the notion that you can't travel faster than the speed of light.
We don't know yet whether or not faster than light travel is going to be an impossibility that we conquer. But if we do, well, then we've just completely changed humanity's future. When I was young, I remember watching Star Trek and thinking, oh, this is cool. I want to be a part of this. If I could make a career helping make that happen, that's a no-brainer. The shortest way to explain what I do is converting science fiction into attackable science. Taking the ideas from like Star Trek and trying to figure out how do we start chipping away to see if we can make those things real.
That was fun. Do you have any idea how ridiculous it is to hide a starship on the bottom of the ocean?
Scotty! Where's Spock?
Still in the volcano, sir.
As an example of how notions of Star Trek are creeping into the sciences, there's a graduate-level textbook on general relativity that has homework problems about warp drives and traversable wormholes, concepts that were definitely inspired by Star Trek.
Lieutenant, so we have an open channel to Mr. Spock.
The heat's fine as comms, but do we still have contact?
When I was at NASA, my colleagues and I were looking at emerging physics that might enable faster-than-light flight. Of the Star Trek thing, you know, to boldly go where no one has gone before, that's the easy part. That could be exploring a piece of mountain range that people haven't gone on before, or going a little bit farther than a spacecraft has gone before. As opposed to interstellar flight, which is a completely different level of challenge. That's the really hard part. We still don't know if or how such breakthroughs will be possible, but we've at least advanced to where it's not just science fiction anymore.
At CERN in Europe, some of the world's biggest and best fundamental physics experiments are performed. These include things like the Large Hadron Collider. There's been looking for the Higgs particle, but other experiments as well.
In 2011, there was a major announcement from scientists at CERN. They seemingly found a weird type of particle, neutrinos, that looked like they were traveling faster than the speed of light. If true, it could mean a tremendous breakthrough. In Star Trek, the Starship Enterprise travels much faster than the speed of light. But we don't think that any material object can be accelerated to above the speed of light.
When I first heard about that announcement of a possible faster-than-light measurement, I was like, oh, that's interesting.
Frankly, you should always be very, very cautious when you hear such stories. Every once in a while, some experiment shows up that suggests that you can go faster than the speed of light. And isn't this amazing? Einstein has been debunked.
It turned out that, as most scientists suspected, there was something wrong with the experiment. There was a loose cable, and so the supposedly superluminal neutrinos, in fact, were traveling at a speed at or probably somewhat less than the speed of light.
Once that was determined, then the idea of faster-than-light neutrinos has pretty much gone on the back burner again. It looks like Einstein has been vindicated.
The theory of relativity is very clear. The speed of light has been verified thousands of times in thousands of different experiments as that speed limit.
And yet, on the scale of even just our galaxy, it's really slow.
A light year is the distance light travels in 1 year.
So 1 light year is about 60 trillion miles. And it's a lot easier to say 1 light year than it is to say 60 trillion miles.
But the thing is, that's not so far into the universe. It's 4 times further to the nearest star. And then it's tens of thousands of times further to all the stars in our galaxy. And then it's millions of times further out into the universe at large.
So if the only way we can get there is with our existing rocket technology, it would take about 80,000 years to reach our nearest neighboring star. If we want to be able to do interstellar flight as easy as they do in Star Trek, we're going to have to figure out how to manipulate gravitational inertial forces, and we're going to have to figure out how to go faster than light, and we're going to have to find enough energy that we can control and manipulate to make those devices work. If it turns out that faster-than-light flight is impossible, well, the whole fun Star Trek kind of stuff ain't going to happen.
What is the current star date?
Star date 223304. Where are you from?
Space is a time machine. Looking out in space is looking back in time.
The luminous stars you see in the night sky reside hundreds and typically thousands of light years away, which by definition means that the light has been traveling toward us for hundreds or thousands of years. You're actually not seeing the stars as they are.
We're seeing layer upon layer of cosmic time because light has taken time to reach us.
So, for example, when you look at the Andromeda Nebula, you see it as it was and where it was 1 million years ago. We're living in a time machine.
With this telescope, we found our first planet orbiting the star 70 Virginis. The light from that star was traveling for 59 years to come here to Lick Observatory. And in fact, this telescope was being built just about the time when the light left that star, traveled all this way to the Earth for the moment 59 years later when we detected the planet. Of course, by the same token, if there are any intelligent civilizations living near the star 70 Virginis, they would look back toward the Earth and see the Earth as it was 59 years ago. They would see Dwight D. Eisenhower as president. They would see the development of the space age just happening here on the Earth. So it's rather exciting to realize that another civilization viewing the Earth would be watching us in some kind of a time machine way, seeing us here on the Earth as we were, not as we are.
Remember this, given the laws of physics today, it's not possible to go beyond the speed of light, but if we could get to 10% of the speed of light and not violate any rules of special relativity that tell us we can't go faster than that, then we could reach Alpha Centauri, which is the closest stellar system, in 43 years, rather than maybe 100,000 years. We have to come up with means of propulsion that would at least give us a substantial percentage of the speed of light to get where we want to go. Then we can start talking about missions in decades rather than centuries or thousands of years.
The moment when humans finally reach a planet orbiting another star will be absolutely tremendous. I will just say, wow, humans are finally there at an alien world. Just amazing.
Systems up, sir. All power is restored, Commander.
My mind is constantly blown when we're working on science fiction stories that are stunning or crazy or shocking or bizarre. And almost every time you will see or hear that there is something in science that out-weirds the thing that you thought was going to really blow people away.
There's a phenomenon in Einstein's relativity called time dilation. And the idea is basically incredible, but it's true.
The closer you go to the speed of light, the slower time appears to pass for whatever's traveling at that speed.
The rate at which moving clocks tick slow down the faster they go. As the speed of a moving object approaches the speed of light, 0 time passes for that moving object. For a traveler going from Earth to a distant star, many, many light years away, time dilation is actually a good thing.
It means you could travel at nearly the speed of light to nearby stars or even distant stars, and very little time will have transpired according to you, your body, your clocks, your machines.
The problem is if they want to come back.
Let's say on Earth we have an astronomer and his daughter is going to take a trip to the star system at 70 Virginis, which is 59 light years away. She's traveling at nearly light speed and then turns around and comes back. Well, for her, hardly any time has transpired, while the people on Earth, almost 120 years have gone by.
So this is a form of time travel.
They will return to Earth having aged very little, whereas hundreds or even thousands of years may have gone by on Earth, and all their friends and relatives will be gone.
That's time dilation, and it's been proved in particle accelerators, flat out proved.
We know that this happens. What we don't know is why does it happen? What causes this to happen?
I've been interested in science my whole life, but my interest in astronomy started as a freshman in high school. I received a small telescope as a gift, and the third star that I pointed it to turned out to be Saturn. That just knocked my socks off. I watched Star Trek with some friends of mine when we were in graduate school. It was sort of a nice relief from our studies, and it was really an interesting show to watch. Sometimes concepts in science fiction can help inspire new ideas in science and technology. That's certainly the case in Star Trek.
Fair enough, guys. Thank you very much.
The desire to understand the universe and to explore the universe and figure out what it's all about is part of my work and the work of most scientists. And indeed, in Star Trek, that's part of the goal. You want to go out and explore strange new worlds and go boldly where no one has gone before.
And they're all looking camera right.
Pretty cool. 3, 2, 1, camera, action!
Systems up, sir. All power restored, Captain.
Captain Dales, great job. That was terrific. We have a guest of honor here today, an astronaut here, Greg Shamatov, who actually brought a Star Trek phaser up to space.
You're on the bridge of the Star Trek Enterprise and have the applause be for me. That's really weird. The phaser's here, actually. Oh.
Bring it out! Come on, let's see it.
Come on. This is mine. This is the coolest thing I've ever seen in space. No, I brought this up with me on the last flight of Endeavour, so that was just the second to last flight. And by the way, I have to just say to you all that I didn't expect to have a chance to tell you all this, but it's Star Trek is the inspiration for my life. I mean, it really is. And what you guys are doing here, it's not just an incredible, spectacular movie, which the last one was just, I was just saying, it's like the best movie I think I've ever seen. But it's also inspiring a whole new generation of kids, like I was when I was a little kid.
Okay, here we go. 1, 2. The best part about space is that it's for real. All of us have this view of what it's really like up there from what we see and from the movies. To see it with your own eyes and confirm that is really the truth. That's really the way the Earth is. It's just floating there in space by itself. It's awesome.
Star Trek has been so tremendously helpful for planetary science because when we come to talk to people and tell them about the latest planet found, people are excited about it. They understand what's going on because they've watched Star Trek and known that there were planets around other stars already.
If the day ever comes that a human can step on a planet orbiting another star, it would be a paradigm shift for humanity. Those first steps on another planet would open the door to a new era of human exploration of the cosmos.
All right, there, we can lose them there.
If you are suggesting that we utilize the passage between the approaching structures, this ship will not fit.
We'll fit.
Captain, we will not fit.
We'll fit!
We could show audiences the idea of a photorealistic spectacle of space. But the journey into space, the whole idea, and this happens to me all the time, it happened to me last night, I'll look up at the stars and I'll just stop and think, this is unbelievable. Like we are on this orb in space. What the hell? It's crazy. Like the idea of it is just mind-blowing.
Why should we spend our time hunting for planets orbiting other stars?
We have to look for other planets because we don't exactly know how long our planet has a future.
Something could go disastrously wrong on Earth, extinguishing our species completely. A large asteroid or comet could hit the Earth, as one did 65 million years ago and led to the demise of the dinosaurs and, in fact, 2/3 of all living species.
There's our own climate change. Will it continue to the extent where it will become uninhabitable for us?
Or there could be a gigantic coronal mass ejection from the sun. We could wipe ourselves out through nuclear war.
So for all these reasons, we need to build up the technologies that will allow us the interstellar travel that we hope will come in the future.
We want to find and examine planets around other stars, in part out of a sense of self-preservation. If our seeds have been sown elsewhere, then we will survive.
This is the impulse that propels us to look for planets outside our solar system. Are there any others like Earth? Might these other places be future abodes of human civilization. I trained as an astrophysicist, studying planets, asteroids, comets, that sort of thing. But I had an artistic hobby on the side of writing, and civilization sometimes takes your hobby and makes it your profession. At least they're willing to pay more for my novels than they ever did for research grants. I was 15 years old when Star Trek came out. I was already planning to be a scientist before Star Trek came along. The odds were 1 in 10 bazillion that I would love Star Trek. Of course I loved Star Trek.
So you guys get to around here, if you sort of turn off.
It certainly expanded my horizons.
Rolling.
It showed me that the civilization around me was getting ready to embrace adventures that involved change.
Jim, where were you? For what? Your medical exam.
Gene Roddenberry portrayed a civilization in which our great-great-grandchildren were better than us.
Roddenberry's vision of the future was optimistic.
Action.
His conceit was that there was no more conflict. It's a hard thing to be a parent and not desperately hope for a future that is as close to Roddenberry's as possible.
Stand by for liftoff.
17 or 18 years ago, I really thought there was a way to hunt for planets around other stars. And when I told my professional colleagues, other astrophysicists, that I was going to develop a technique, my colleagues would look down at their shoes and scuffle their feet and change the subject. Nobody was thinking about planets. It was a crazy topic. Looking for planets around other stars was akin to hunting for little green men, teleportation. You know, these kind of ideas seemed like the stuff of science fiction.
Planets around our own sun are just planets, but when we see planets around other suns, we call those exoplanets.
Eventually, of course, we'd like to settle on at least one other exoplanet.
Jeff Marcy's first one was discovered down at Lick Observatory 18 years ago.
We're here at the Lick Observatory telescope, the Shane telescope. Many historic discoveries have been made here. I first came here in the 1980s, specifically to discover the first planets ever found around other stars. I knew this was the best telescope in the world to hunt for planets. The telescope is huge, with enormous light-gathering power to collect the photons from faint stars, but it also has something precious, a spectrometer.
He had this wonderful spectroscope that was good enough to notice the tiny changes in the light from the slightly wiggling stars. And he found planet after planet.
When you stand by train tracks and hear the train whistle as the train approaches, you hear a different sound than when the train is going away. You hear the train whistle sound like this. You can tell if the train is a coming or a going just from the pitch of the train whistle. We use the same trick with light waves from stars. We can determine whether a star is approaching or receding away from us by the change in the pitch of the light waves. And by that method, we can learn if a star is moving around instead of being stationary, and a star would move around if it was yanked on gravitationally by a planet that's orbiting it, even if we can't see the planet.
What types of planets are there out there? There are gas giants like Jupiter.
We're just finding all kinds of planets. There are planets that we call mini Neptunes that are about 2 to 3 times the size of Earth.
Some of these planets will be possibly full of metals.
Like carbon planets that may even have a layer of diamond in their interior.
Other planets may be coated in either ice or even entire oceans of water to a depth of hundreds of miles.
I can tell you one thing. When we discover a planet around another star, you can watch the New York Stock Exchange. It doesn't budge, doesn't go up, doesn't go down. The NASDAQ doesn't move. You can't make a profit by discovering planets. But there's something precious about those planets. They tell us something about our own solar system and especially about our Earth. I was venturing into territory by hunting for planets that was really inappropriate for a professional. So my colleagues told me, your professional life ought to be a little more careful and conservative.
Get ready to freeze it, please. And freeze it. So here's the thing. So we're going to continue this way.
Pioneers may be underdogs until they succeed, but they're driven by something. To make a discovery, to contribute something to society and to science for the next generation.
Yeah, they'd be right here. So here we are at the Nibiran jungle. The idea was to create a jungle that didn't look like anything on Earth, so the idea of a red jungle, kind of a callback to the vibe of what they did in the old Star Trek show, but try and do it in a way that looked a little more real.
And chase!
I think when you look at what it is that Roddenberry wrote about going boldly where no one has gone before, humanity's trying to do that. I would hope we'd get the resources and the technology to actually travel to other moons and planets and solar systems. It's an incredibly exciting thing to think of what's out there.
I hate this! I know you do!
To guarantee our long-term survival, we should try to populate another planet as soon as possible. But there's a number of characteristics that make Earth special, that make us habitable, where the temperatures are right for liquid water to exist on the surface of a planet.
Exoplanets that are just the right distance from a star with an atmosphere like the Earth, we say they are in the Goldilocks zone. That comes from the fairy tale, where one oatmeal is just right.
Jeff Marcy has recently shown us that the number of planets in the Goldilocks zone that we talk about may be as high as 50%. That's a high number.
Nowadays, we have a spacecraft, the Kepler spacecraft. It looks at 150,000 stars all the time and watches for the brightness of the starlight.
NASA's Kepler mission is aiming to answer one of the most fundamental questions we have, and that is how common are other Earths? Although we can imagine all sorts of planets that could support life, we're more guaranteed that it could support life if it's a lot like our own planet.
It's amazing to realize that just 20 years ago, the only planets we humans knew about in the entire universe were the 8 major planets that orbit our sun. You can add in Pluto as the 9th planet, but that's all we knew about.
Extrapolating from the results of the Kepler mission, we now estimate that many, if not most, stars that we see in the sky have planets orbiting them. There could be 100 billion planets in our own galaxy alone, and there could be perhaps something like 1 billion Earth-like planets.
Right now, today, it would take perhaps hundreds of thousands of years for us to reach that star.
If somehow, through some miracle, you and I could move at 99.999% of the speed of light, 1 year aboard our starship would translate to 223 years here on Earth.
And so if you're going to do interstellar jaunts where you go at it near light speed and you take some pictures and you're going to come back now and show them to your family might have died and long ago, and they won't be there to see the pictures.
But it's very cool looking.
But in Star Trek, the Starship Enterprise overcomes this time dilation problem by using the warp drive.
Tracked all moorings, Mr. Sulu.
Yes, sir.
So they can zoom there and back again with only a short amount of time having gone by on Earth.
Mr. Chekhov, how are we looking down there?
All systems nominal, Captain.
Copy that.
Warp available at your command.
Thank you, Mr. Chekhov. That's right.
They do this by moving much faster than the speed of light. However, for us, that won't work. Our current understanding of physics makes the idea impossible. You can't just accelerate to speeds faster than light because it would take an infinite amount of energy.
Another limiting factor when thinking about faster than light travel, there are some debates about whether or not these start to create time travel paradoxes.
And that's because the mathematical theory of relativity suggests that if you could go faster than the speed of light, then you could go backwards in time.
Where you can arrive back from your journey before you ever left, stopping yourself from taking the journey, in which case, well, you see where the paradoxes come from.
If somehow the speed of light could be violated, then an event that was caused by some previous event could happen before the original event that caused it. And that, of course, makes no sense at all.
We don't think the universe allows this, because if it allowed this, then all sorts of strange things would be possible. It would be like having a pot of water on the stove start to boil before I turned on the heat.
For Star Trek, I think that the story needs to serve an emotional and intellectual truth.
Okay, here goes. Set.
But it is a concern that scientifically it be accurate.
And action. Log on to their signal. Beam them back right now.
We cannot beam back one without the other.
But at a certain point, you have to be able to accept a leap of faith.
And cut. Good.
You know, we know space is silent. When you look at the first Star Trek movie, my first idea when I first started working on the original 2009 version, I really wanted to do silent space. I thought it was cold and lonely and scary and a void. Well, when you watch sequences without sound, you realize why you put sound in. It just is amazing how quickly it loses its impact. But I wanted to make sure that we had moments that basically say to the audience, you and I both know, space is silent. And then go back into sound. It was one of those things that we found a way to handle that allowed for us to have our cake and eat it too.
Now, it seems on the face of things that warp drive is maybe Star Trek's deepest look into the future.
Warp drive would really open up the cosmos for us if we could do it. It would allow us to explore within a single generation. Many of the other scenarios, once you're gone, it's going to be a long time before you can even send word back home.
Back in 1994, a Mexican physicist named Miguel Alcubierre studied this question. Can you construct a bubble of space-time like we're sitting in here today? Can you put your ship inside that bubble that warps space-time?
Imagine you wanted to move a car across a landscape. Well, the warp drive idea is that you manipulate the landscape and carry a chunk of land and move that, and the car just rides along with it.
So the spacecraft sort of rides a wave towards its destination.
You're no longer moving through space-time. You're moving chunks of space-time itself, and the rules are different for that.
There's nothing in Einstein that says space-time itself is limited by the speed of light.
You're basically not breaking the speed of light. You're just causing more space to appear behind you and less space in front of you. So traveling much slower than the speed of light, you're still going to get there much faster.
And so with that, it would allow you to go to a habitable planet, visit it, and come back to Earth and still be able to talk to your living relatives about it.
If you could make a warp drive work, you could produce a starship that could travel very much like the Enterprise. Suddenly, the universe would open up so that within their own lifetime, people could travel to many different star systems.
The creator, Kubrick himself, was influenced by the warp drive on Star Trek.
Whether it can be produced, well, that's a very difficult question.
The trouble is, we know of no way of squishing down the space in front of the spacecraft and stretching it behind it without actually going there first. In which case, you've done that trip at speeds less than that of light in the first place. So you can't just go zipping anywhere you want in the galaxy. You have to, in a sense, first set up the railroad track before the train can travel on it.
Can we humans imagine traveling to the stars, a la Star Trek? Well, maybe, but the distances are enormous. The amount of energy required is unbelievable. The physiological challenges of traveling to the stars is incredible. It may turn out, and this is sad to say, that human spaceflight among the stars, like Star Trek, is simply impractical, if not indeed virtually impossible.
Consider our Voyager spacecraft, which has taken 3 decades to reach just the outer part of our solar system. If it was headed towards our nearest neighboring star at the speed it's going now, it would take approximately 80,000 years to reach there, which, if cavemen had launched the Voyager, by now it might be reaching Alpha Centauri.
Many things that used to be thought of as science fiction are now science fact.
Like that a human could survive going over 20 miles an hour before there were trains.
People thought traveling to the moon was impossible.
Or breaking the sound barrier.
Through the sound barrier. The first time ever in level flight.
But none of these ideas fundamentally broke any known laws of physics. They were just technologically difficult.
The Wright brothers overcame a technological challenge. Armstrong stepping on the moon overcame a technological challenge. Nobody thought that those two accomplishments somehow violated fundamental laws of physics. Traveling to the stars, like Star Trek, is pushing up against daunting difficulties.
Say hi.
Notably, the speed of light and the amount of energy required to travel among the stars.
You say engage. Louder. They gotta hear you over there. We're not going anywhere unless you say it. This is gonna be a very long trip at the docking station.
So even if we can't beat the speed of light, there may still be some possibilities for human beings to travel across the galaxy.
You would need something much bigger than the Enterprise.
So you create a self-sustaining vessel where you have a segment of humanity that can go out to explore.
A colony that grows its own food and recycles everything that it has and lasts for many, many generations of humans.
Living on one of these might be more like living in a small town if it was built the right way. There would be people born in space. Entire generations live and die. And eventually the generation ship pulls into orbit around Alpha Centauri or wherever it's going. Humans will eventually get there, even if we never develop travel close to the speed of light or something like a warp drive. I think the generation ship is a very provocative idea. Slow travel, I call it slow boat to Centauri. We just have to relax our ideas about time. We're all used to thinking in short terms. Everything has to be now. Why not take your time?
Ways that use known physics to get off the planet and explore deep space, there's numerous ideas that are out there.
Imagining a huge gossamer-like sail the size of several states, built by future engineering in the next century or two. And then let's imagine turning a multi-million gigawatt laser on that sail to push it.
Now on Star Trek, they held antimatter to power their spaceship in dilithium crystals.
We know that antimatter can be made. We cannot make very much of it or get very much of it yet, but theoretically it would be the ideal Starship fuel. So I think when they decided to use antimatter in their warp drives, the creators of Star Trek were thinking ahead. They knew what they were up to, and it was a very wise choice.
To get off our planet and explore deep space, short of having warp drives and solar sails, you can use ideas of fusion, the same sort of nuclear reaction that powers our sun. At the National Ignition Facility, they're trying to use very high-powered lasers to create a controllable fusion event.
Using lasers to ignite fusion could someday be the guiding principle behind building a fusion rocket.
NIF is a lot of things to a lot of people. To some people, it's the world's biggest and most energetic laser. And to some people, it's a target chamber here where you can do physics that's never been done before. And some people, it's a movie set. One thing you have to remember about Star Trek, what was their objective? Exploring new worlds. So here we can explore them. Behind me, we have been to the center of Saturn. Now that sounds kind of silly, you know, well, you really weren't at the center of Saturn. But we created conditions that exist in the center of Saturn. We're explorers, and what we're exploring is the universe and hopefully the future. So even though we're not going to places the Starship Enterprise can go to, we are effectively going to places boldly where no one has gone before.
Action! Scott, I need you to approve those weapons.
Do you know what this is, Captain?
I don't have time for a lecture, Scotty.
Do you know what this is?
It's a warp core.
It is a radioactive catastrophe waiting to happen.
It'll just be tremendous to see how JJ and the team have interpreted our facility.
Why, Captain?
It took about 10 years to build NEF, and now it's been running for about 3 years.
All systems nominal, Captain. Warp available at your command.
Thank you, Mr. Chekhov.
The future of our species will be fundamentally changed with fusion energy.
Oh, this, Lawson's criterion, and it's how you get ignition of fusion.
That is sort of our goal, and we hope to be the first to do it.
Listening to the captain, listening.
When we get fusion, you'd have no pollution. The global climate issue would start to become under control.
3, 2, 1, action.
You don't have to worry about getting oil or coal. Everyone will be happier.
And cut.
So our goal is just a better world.
If they're able to do what they're trying to do at the National Ignition Facility, it will be the thing that will be remembered about shooting there, not just that we got a couple really great scenes and had a really fun time shooting there, but we actually got to be in the location where this pretty miraculous thing occurred.
I was going to say this has been far and away the most amazing experience. I have to say thank you to everyone here at NIF and the whole group. I mean, literally the most amazing location, the greatest opportunity. How lucky are we that we got to not just work together, but work here together. So thank you.
We thank you for coming. It's been great having you. One of the things I want to give you, and it's a small piece of a great system, is our own dilithium crystal. Wow! This is the laser blast that makes it all happen.
These people are actually working to change lives and to do something that would alter the destiny of the planet the way, you know, the wheel did and the light bulb did. What I love about it is that a lot of the people who were there were saying that they started doing what they do because of Star Trek, that they loved Star Trek and that it inspired them to get involved in science. It was an honor to shoot them.
The mission of Star Trek is to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no one has gone before. And all of those really play a role in the work that we do at the SETI Institute. What we're looking for is very faint signals from outer space, radio signals from other civilizations. Something that stands out and that says distinctively, this is not just made by nature, but this is something that's created by a technological civilization.
You might ask yourself, how many advanced civilizations are there in our Milky Way galaxy? Milky Way has some 200 billion stars, each star being more or less like our sun, smaller, bigger.
Maybe life forms easily. Was it a fluke that life started here on Earth? Or is the fact that we can detect carbon compounds throughout the universe, that these can form into organic compounds, that all of these can combine easily to produce life, is that something that means life is everywhere?
Are we the only intelligent life ever to have arisen, or one of many, many?
Speculations about alien life goes back to the ancient Greeks. Giordano Bruno was burned at the stake for speculating about aliens. Things have gotten easier on the sci-fi types since then.
The idea that we humans might pick up or indeed send signals really got started in the 1800s.
One of the great suggestions for communicating with people living on the moon in the early 19th century was to go to the Sahara Desert, carve a huge canal, fill it with kerosene, and light it to let people living on the moon know that we're intelligent beings on Earth.
By the time we get to the 20th century, a lot of people believed that Mars was indeed sending out radio signals. Marconi believed he received signals from Mars. Tesla spoke of signals from Mars. And the whole idea that there are beings on other planets and they're out there and let's communicate, very much in the air.
Those ideas sort of took a back seat for a few decades. And then around 1960, there was an explosion of interest in sending signals to and receiving signals from advanced civilizations.
The serious search for radio signals from extraterrestrials started in 1960, when a young astronomer, Frank Drake, started Project Ozma.
Frank Drake. He conducted the first SETI search using a telescope to look for radio signals from two nearby sun-like stars.
Frank Drake came up with an equation, now called the Drake equation,
to calculate how many advanced species there are populating our galaxy.
And to find that, we need to look at 7 factors. The first term of the Drake equation is R sub star, the rate of star formation.
You'd like to find out how often stars form that might produce planets that could produce intelligence.
Then we want to know, of those stars, what fraction of those have planets?
We now know the answer to that. Almost all stars have planets orbiting them.
But of those stars that have planets, how many planets are inhabitable? How many of them are Earth-like?
Where the temperatures are right for liquid water to exist on the surface of a planet.
They need to have liquid water, some kind of lukewarm temperatures, so that the organic chemistry of life can get kick-started and flourish.
Especially good for the long evolutionary process needed, we think, to develop high levels of intelligence.
The next term of the Drake equation is F sub L. What fraction of those planets have life that arose?
And then we say, well, how many of those that do produce life produce intelligent life?
Primitive life, microbes and bacteria, may be very common, but that intelligence at our level and mechanical ability at our level may be very, very rare.
There could be intelligent dolphins on other worlds making the greatest sonatas and singing to one another, but if they can't build radio telescopes, we're never going to know about them. So the next term is F sub C, the fraction of those intelligence that are able to communicate and that have the motivation and the willingness to transmit messages.
And then there's one last factor of the Drake equation, which is the most frightening of all of them. How long does a civilization that develops technology like we humans have last?
We humans have much capacity to destroy ourselves right now, and it's not at all clear that we'll last very much longer. If this is typical of intelligent civilizations, then they may be common, but they're like flash bulbs in the night. They extinguish themselves shortly after achieving technologically advanced societies.
Depending upon what numbers you put into this equation, you can get very dramatically different answers on how many civilizations there are.
That lifetime of an advanced civilization, that last factor in the Drake equation, is the one that ultimately determines whether our Milky Way galaxy is heavily populated with advanced technological aliens or is devoid of them.
When I run my own numbers, I get 10 in the galaxy. The amount of energy it takes to send signals or even do starflight starts to become so extreme that if a little bit of that energy gets used wrong, it could destroy a whole planet. The amount of energy a person has at their disposal, the cavemen, muscles, later arrows, guns, now we're into bombs, and even individuals can take over airplanes. Eventually, as the decades go by, who knows if an individual couldn't get hold of a nuclear weapon. And once you're up to those very high energy levels where you might be able to do these things, you're also into a realm where you have to be extremely well behaved with yourself to keep yourself from going extinct. And I don't think that that would happen all that often. So that's why I get such a low number when I run my own estimates.
If, along with intelligence, one almost always gets these self-destructive tendencies, then that's a very, very sad statement. And it may mean that our own fate is to be here only a very short time.
Why is it that after 50 years of listening with Project SETI, we've seen no signs? Maybe life is more difficult to start than we think. Or maybe interstellar travel is impossible, or limited to incredibly slow speeds. Maybe it's very difficult. There are more than 100 cataloged explanations for the Great Silence. But in 1977, one of the SETI apparatuses did pick up something briefly that shot off the charts.
If Star Trek is right, and there are Vulcans and Klingons out there, what other accomplishment in human history would match the discovery of our kindred spirits out there among the stars?
Hair school. Hair school. Hair school. Wow, that's awesome.
The discovery of fire was good. Finding Spock would be better.
Good.
It's very exciting. I was on the bridge of the Enterprise, so that's not something a girl gets to do every day.
The odds of there being at least one form of intelligent life outside Earth, somewhere in the observable universe, are higher than your odds of winning the lottery. There's more than 100 billion stars in our own galaxy alone.
Lieutenant Uhura, open a shipwide channel.
And we think that in our universe, there's upwards of 100 billion galaxies. So the chance for life to originate and evolve into intelligent life has to be 100%.
I just do a 360, Kasha. Just turn around on the spot.
The harder question is, can we interact with that life?
In 1977, one of the SETI apparatuses did pick up something briefly that shot off the charts.
Jerry Eman, a volunteer, was analyzing radio signals from the Big Ear telescope in Ohio. And he saw a very strong signal, very much unlike the noise that one generally hears.
A burst of radio waves that seemed just what you would expect from an advanced civilization trying to say hello.
It's called the wow signal because one of the scientists wrote wow in the margins.
It's become iconic of what we're searching for in SETI, a signal that stands out from the radio static as being an anomaly that we can't explain in natural terms.
And to this day, we don't know whether that signal was real from an advanced species or some kind of noise like the backfire from a nearby automobile.
They think it's been determined that it was not of human origin, didn't come from a spy satellite, didn't come from a weather satellite, that it was probably passing by this point in space where they've aimed telescopes many times since and found nothing.
In science, we want to get the same results many times in order to believe them. The problem with the WOW signal is that it was seen only once. It wasn't a repeated signal that could be verified by many different radio astronomers looking in that patch of the sky.
You can get interesting signals, but if you can't replicate them, it's hard to make the leap to saying these are from another civilization.
And so it's a little frustrating, but also inspiring, because if we continue to use radio telescopes to search for those signals, maybe someday we'll pick up another WOW signal.
One camera, hey, Mark.
I don't know how advanced or how much more primitive life out there might be, but there's not a question that inevitably there will be some contact.
Look at Mandy. Now look at the captain's chair, and then back at your screen.
And I don't believe I've ever seen a UFO. I don't believe that the stories I wish were true were true.
Are you good?
Mm-hmm.
Okay. So I'll cue you in to open your mouth, right? Okay, here we go.
But you don't need to hear anything to just know that we're part of a big mystery.
"15 years ago, we knew of no planets outside our solar system. Now it's thousands. So we're learning about this jungle very rapidly. I'm all in favor of listening, of checking for any signs that anybody's out there. But I'm not so sure about shouting yoo-hoo. There are a lot of low probability ways that that could go very badly. Let's not make a decision that our grandchildren might regret."
How loudly do we want to call out into the universe without knowing what's out there? I think we should look at histories on our planet of first contact and how badly they often turned out.
We humans would travel to another island or continent, encounter another civilization, and we didn't always treat them well. And so there's a sort of inbred fear that we now have that the alien civilizations out there might treat us in ways that are not so different from the way we ourselves have treated each other.
It is an absolute possibility to look into a night sky and see all the stars and understand that each one is a sun and not know for a fact that we are surrounded by life everywhere we look.
That's very cool.
For anyone who looks out at those stars and is self-involved enough to think that we're the only life in the universe is, I think, really misguided.
B-56 Charlie, take 2.
Great camera, Landmark. Action.
Be seated.
Once we find a clear signal from an intelligent alien, we then have to decipher it. That's going to be really rough because it's unlikely to be in English or French or Swahili or even Klingon.
Communicating with an alien life form, the thing that comes to mind that we would both share is physical geometry, you know, basic circles or whatever, and math is beyond that. But I have no idea how to say with geometry, please don't kill me.
intelligent species that's thousands or even millions of years more advanced than ours probably has ways of knowing about us without even coming here.
With their advanced technology, they could easily build a giant telescope that's maybe even a whole solar system in size. They'd be able to see the continents, they'd be able to see the lakes, they might even be able to read the license plates on the automobiles here on the Earth from their vantage point on another star. Moreover, other civilizations could pick up our radio and television transmissions.
The radiosphere is this sphere of radio signals that's been leaking out from Earth ever since we began broadcasting radio transmissions.
Traveling away from the Earth at the speed of light, we can't get those communications back.
So that signal is going out and it's expanded about 80 light years beyond Earth. And as it goes off into space, it becomes weaker and weaker and weaker and weaker. But if you're sufficiently advanced technology, you might be able to pick up even those weak radio signals.
And so you can imagine the Earth and a bubble that's ever expanding. Within that bubble, there are thousands of stars, and we now know that most of those stars have Earth-sized planets.
So any civilization who's in a star within that distance could have already detected us as a technological civilization.
The outside universe knows about Gilligan's Island and I Love Lucy and game shows.
I don't know what opinion they'll have of us based on our radio emissions, but they certainly will have heard us say a lot of things.
Right. Action.
Chair's all yours, sir.
Mr. Scott, how's our core?
Purring like a kitten, Captain. She's ready for a long journey.
We worry, of course, that human spaceflight to the stars may be extremely difficult, if not indeed impossible. So unmanned probes give us a chance to travel to the stars effectively.
We sent out our Voyager spacecraft in 1977. They've been traveling ever since.
This is the most exciting mission that I've ever worked with. It's particularly exciting because we're really going into the unknown.
The Voyager spacecraft is, in a sense, our first interstellar craft.
The mission of the Voyager spacecraft was to explore the planets of our solar system, gathering all kinds of scientific data, taking wonderful pictures.
It was really a first look, and a very, very good first look at that.
When the Voyager spacecraft finished its major mission, it turned its camera back toward Earth and took a photograph from afar. And at that distance, our Earth was just a pale blue dot against this vast expanse of stars. In a sense, it really showed the insignificance of life on our planet in a cosmic context. But on that same spacecraft, there was a recording that gave just the opposite message of what we most value about life here on Earth. In the last few weeks leading up to the mission, Carl Sagan, an astronomer who's been involved with the search for life beyond Earth for many years, put together a team to create a message from Earth. It's a long play album encoded in gold. It's meant for another civilization that might find it 100,000, a million years from now as it drifts off in interstellar space. Any extraterrestrial who comes in contact with the Voyager recording first finds it enclosed in a metal case. And on the outside of that metal case, there are instructions for how to play it. You put the needle on the phonograph record, and the needle is included with the spacecraft, and directions of how to turn, including how rapidly. Of course, they don't know anything about hours or seconds, so it's defined in terms of the speed at which hydrogen makes a transition from one state to another. And hydrogen, being the most abundant element in the universe, is something that extraterrestrials should understand as well.
As the Secretary General of the United Nations, an organization of 147 member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet.
There are greetings in 55 languages. Greetings.
Bonjour tout le monde.
Over 100 images. Music from around the world. A sampling of what it means to be human.
Hello from the children of planet Earth.
It's a fascinating thing to work on a movie like Star Trek Into Darkness because it's science fiction, but it's based on principles and ideas that I think are wildly compelling, which is people, all of us, working together, that we are unified to sort of explore this universe. There's something deeply relatable and a human natural curiosity that when you actually think about it, oh my God, going off into space, it is mind-blowing.
Remember that Voyager has taken 3 decades to reach the outer part of our solar system, farther than any spacecraft has gone before. We don't know yet if we can travel as far as the Starship Enterprise, but if some alien civilization comes across Voyager, they will know that at some point there was another intelligent spacefaring, or at least space probe sending civilization out there.
Part of the beauty of the Voyager music, it's not just the individual pieces, but the way they're connected to one another. My favorite passage is right in the middle of the musical selections, where there's first this mournful, kind of yearning bagpipe music. And then it shifts away to a very strident, rhythmic, beating piece. And then, after a pause, it shifts into this very orchestrated, ordered, Bach, well-tempered clavier. And so the great thing about that passage is that it captures so many emotions and captures that at times life is mournful and we're yearning, and at times it's strident and full of strife. But somehow we manage to put things together and find an order and peace in spite of all of that. In addition to the music on the Voyager recording, there's a 12-minute sound montage of the evolution of life on Earth. It starts with this kind of twirling, eerie music that's actually Kepler's music of the spheres. It's the sounds of the planets put to music. And then it talks about where life arose, our early planet, volcanoes and boiling mud pots, and then sounds of a variety of types of creatures here on Earth, crickets and reptiles and the hyena. And then the idea of human beings. You hear Morse code, you hear technology, transportation. The firing of a Saturn V rocket as we lift off into space. And then finally, the closing segment shows this sort of repetitious, rasping sound of a pulsar as we again look out into the cosmos and try to understand where we came from.
We jumped into some of the most complicated stuff in one oval-shaped room, and everyone was critical and incredibly important, and I could not be more grateful for what you did. This is like the heart of the movie, not just this place, but the scenes that took place here, and every one of you was a huge piece of making it, you know, look as good as it does, and it looks great. You have to trust me; it's amazing. I'm not going to show you, but but you'll see it soon enough. But I just want to say thank you to everyone. Thank you so much for everything you did.
I think it's human nature to see a place in the distance, and that place in the distance is never just a place, it's always a destination. Humanity would never identify a place and not attempt to go there. Not to conquer it, not to transform it, but to explore it.
We're explorers. And it may be that one of the ways we can ensure our longevity as a species is to actually spread out into the universe.
What if we're the first to make it to the other side? And to make a civilization like the Federation in Star Trek? And what if everybody out there is waiting for us to do that? To go out and rescue them, to show them the way. That's a scary prospect. It's a burden. I think we can take it on. I think we can do it.
Starship is for those who come after us. It's a collective enterprise of the human spirit. We should begin working today on the foundations of that enterprise so that 3 centuries from now it will happen.
I don't know what it will really be like 200 years from now. But that positive world image that Star Trek conveyed, I hope, remains a guiding factor on how humanity progresses in the future.
It's lovely to think that we made a difference in our time. It's something about our generation developing the technologies that made the propulsion possible, discovering the planets that led to the inspiration to travel to the stars. That something we did may bear fruit 1,000 years from now in a way that is so precious that you could indeed call it the destiny of humanity.
Thank you, actors, very much indeed. Great job, guys.
I'm like thinking like a more bare bones thing.
Like
for Star Trek 2, like maybe a rock guitar for the whole movie. You know what I'm saying?
Yeah. Yeah.